Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Algebra Unit 2, Lesson 1. It's the first lesson in the second unit. Today, inshallah, we have a lesson called Linear Relation Between Two Variables. Okay. In this lesson, inshallah, we are going to learn the meaning of variable and the relation between two variables and how can we represent this relation on the graph, and we are going to solve many problems about this concept. Let's start the lesson. First, we need to know the meaning of the linear relation. Relation, it means connection between two objects or two things or two variables. Okay, but in mathematics we are classify or form this relation as an equation. Then we can express this relation as an equation like this. We can call it a mathematical equation of two variables x and y. Okay, the two object or the two things we are changed together called related to each other called x and y. But here we have linear relation. Linear relation means relation in the first degree. Then here x and y must be in the first degree. First degree, that means x is in the to the power 1 and y to the power 1. Okay, now we have, as we said, the linear relation is an equation. Then we are going to have an equation. This equation included x and y, and they are connecting with each other by the rule including inside this equation. Okay, for example, if we have here y equal x plus 2, this is an equation. This equation included x and y, then we called it a linear relation between x and y. That means x and y changes together. When x change, then y followed by y change according to the change of x. For example, here if x equals 0, then in that case x equals 0, then y equals 0 plus 2. Then y here equal to 0 plus 2 equal to. Okay, now we can represent the results 0 and 2 inside a bracket like this. Okay, 0 comma 2. This bracket called ordered pair. This ordered pair formed from two numbers. The first number is equal x or called x, and the second number is called y. Okay, then here we have a relation. It's a rule connect between x and y. Y equal x plus 2. If x take a value 0, then y take a value 2 according to the relation 0 plus 2 equal 2. We can represent this values or this results inside bracket like this called all the order pair. We can express this relation or this result by another way, okay, graphically like this. If we have a graph like this included horizontal axis called x and vertical axis called y. In the horizontal axis we have at the middle 0, to the right 1, 2, 3 and so on, to the left -1, -2 and so on. Up we have 1, 2, 3, 4 and so on. Down -1, -2, -3 and so on. And y, down we have 0, -1, -2 and so on. Up 1, 2, 3, 4, 5 and so on. Okay, now I can represent 0 and 2 on the number line. How come? X equals 0 and y equal 2. X equals 0 here and y equal 2 here in this position. Then we can make a point in this position like this. Okay, another example. If x take a new value 1, for example, then y will change according to the change of x. It will be 1 plus 2 equals 3. Then y equals 3 in that case. Okay, we can put 1 and 3 inside bracket like this, and I can represent 1 and 3 on the graph. X equal 1 and y equal 3. Okay, here x equal 1 up to 3 like this. At this position will be like this. Okay, another example, if x equal 2, then y equal 2 plus 2 equal 4, then y equal 4, and I represented on the order pair like this, 2 and 4. 2 and 4, it will be 2 and up to 4 here in this position. Okay, another example, if x equals 3, then y equal 3 plus 2 equal 5, and I represent 3 and 5 on the bracket like this, and I can represent this on the graph 3 and 5 here in this position, as we see. Now we notice that the points, all the points are collinear. Collinear, that means lie in the same straight line. Then I can connect them by a straight line like this, as we see. Okay, so this relation called linear relation. Linear relation, the word linear, okay, is from the word line, okay, because this relation represented as a line, then we called it linear relation. Again, the linear relation is a mathematical equation of two variables x and y in first degree, that mean x and y to the power 1. The relation represented as an equation like this. This equation, okay, if x take a variable, take a value, then y take a value opposite to x. If x change, then y will change. If x take another change, then y takes another change, and so on. Then x is called variable because the values of x are change, and y is a variable because its values are change. Okay, we can represent each two values together by 1 point on the graph like this. The points, all the points of the same relation are on the same straight line. We can connect them as by straight line like this. Let's solve problems on this concept. Number 1, here we have complete the following ordered pairs which satisfy the relation y equals 3x minus 1. Okay, the first order pair with us is 5 and what? Here we have, in this one, we have 5 is x, and this one is y. Now I need y. Okay, so I will put in place of x 5, then y equal 3x, that means 3 times x or 3 times 5 minus 1. 3 times 5 equal 15, then y equal 15 minus 1 equals 14. Then the value here of y equal 14. Another one, 2. If x equal 2, then I will put in place of x 2 here. I will put 2 here in place of x. Then y equal 3 times 2 minus 1. Then y equal 3 times 2, 6 minus 1, 5. Then y here equals 5. Then the order pair, it will be 2 and 5. Another example. If x equals 0, then y equal 3 times 0 minus 1. Then y equal 3 times 0, 0 minus 1 equals negative 1. Then here y equals negative 1. Now we say that 5 and 14, 2 and 5, 0 and negative 1 satisfy the relation. Again, now we say that 5, 14, 2 and 5, 0 and negative 1 satisfy the relation. What does it mean? That means if we have a straight line like this, which represent the relation, that means 5 and 14 lie on the same straight line. That means this point satisfies the relation. 2 and 5 satisfy the relation. That means 2 and 5 belong to the straight line. 0 and negative 1 belong to the straight line. That means it satisfy the relation. But if any of the points outside the straight line, it called doesn't satisfy the relation. Okay? The next example with us. Here we have in example 2, show which of the following order pairs satisfies the relation y minus 4x equals 7. Okay. The first one, we have here x equal 1 and y equal 2. Then I will put x equal 1 and y equal 2 and I will see it give me 7 or not. Here I will put 2 minus 4 times 1 equals what? 4 times 1 equal 4. 2 minus 4 equal negative 2. Okay, then what this point don't give me, okay, doesn't give me the relation, okay, the right side. Then this one doesn't belong to the relation or don't satisfy. This one is not satisfy the relation. Number 2, 3 and 5. Here we have x and y. Okay, I will put in place of y negative 5 in the same relation. Okay, and minus 4 times 3 in place of x. It will be negative 5 minus 4 times 3. Negative 4 times 3 equal negative 12. Negative 5 minus 12 equal negative 17. Then this point doesn't satisfy the relation because negative 17 is not 7. Another one, negative 1 and 3. I will put in place of y 3 minus 4 times negative 1 equal negative 4 times negative 1 equal 4. 3 plus 4 equal 7. Then this one satisfy the relation. That mean this point belong to the straight line, doesn't belong to the straight line, and this point doesn't belong to this straight line, but negative 1 and 3 belong to this straight line. The next one. Now we have special case. The special case is here called the constant relation. The first constant relation, y, for example, y equal number. Okay, for example, if we have a relation y equal to, again, if we have a relation y equal to, as usual, in any relation, x and y varies together. If x change, then y change according to x. But here, we have a relation included y, but it doesn't included x. It's included y here. Okay, it doesn't included x. That means y is always equal to at any value of x. For example, if x equals 0, then y equal to. Y doesn't change because y is constant. Y equal to. Okay, we can represent 0 and 2 on the order pair like this, and graphically I will draw the graph like this, and 0 and 2 will be 0 and 2 here in this position. Okay, another example, if x equal 1, then y here equal also 2 because y is constant. So this one is a special case. It will be here 1 and 2 represented on the straight line on the graph, 1 and 2 here in this position as we see. And if x equal 2, then y also equal 2. It will be 2 and 2 represented here in this position. Now we have 3 points all of them on the same straight line by connect them, but before connecting them I will put these values in a table like this. X and Y, the values of X are 0, 1 and 2, the values of Y are 2, 2 and 2. Y here is constant because the relation is a constant relation, Y is 2. I will represent this values as a straight line like this. Okay, now we find that this straight line is parallel to x-axis again. Then we represent this straight line is parallel to x-axis. Then if we have a relation, a constant relation, y equal number, it's a straight line parallel to x-axis. We can write this as a remark. Y equal number give me line parallel to x-axis. It's very, very important. Another case. If we have x equal number, okay, for example, x equal 3, let x equal 3. Okay, in that case, x forever equal 3 and y will change again. In that case, x is constant equal 3 and y will be changed like this. X equal 3 at y equal 1. X, okay, it will be 3 and 1. It will be represented here 3 and 1. Another example, x equal 3 at y equal 2. It will be 3 and 2. It will be here. Another example, if x equal 3, y may be equal 3. It will be 3 and 3. It will be represented here. Okay, I will represent the table in the values in a table like this. X equal 3, 3 and 3, and I will connect them, okay, to give me a straight line. This straight line parallel to y-axis. Another relation. If the relation is x equal number, then the line is parallel to y-axis. Then they are opposite to each other. Y equal number parallel to x-axis and the x equal number parallel to y-axis. Don't forget this special case. It's very, very important. Let's solve the next example. Here we have example 3. Find two ordered pairs satisfy each of the following relations. The first one. Now I need to find two ordered pairs satisfy the relation. Okay, first I will start with the ordered pairs. I will start with the ordered pair. For example, in place of x I will write any value. For example, 0. And another ordered pair. In place of x, I will write any value, for example, 1. Okay, now I need the value of y here and the value of y here. Okay, by write x in place of x 0, it will be 2 times 0 minus y equal 5. 2 times 0 equal 0. Then I will cross this. Then negative y equal 5. Negative y as much as negative 1y, I will send the negative 1 there by divide. It will be y equal 5 divided by negative 1. It will be negative 5. Then it will be here negative 5. Okay. The other case, if x equal 1, I will put in place of x1. It will be 2 times 1 minus y equal 5. 2 times 1 equals 2 minus y equal 5. I will send 2 there as minus 2. The negative y equals 3. I will send there negative 1 as a divide negative 1. Then y equal negative 3. Then the value of y, it will be negative 3. Then the two ordered pairs are 0, negative 5 and 1, negative 3. The next one. If y equal 2, this is a relation. Okay, here I have two ordered pairs. In both of them, I will write y equal to, here y equal to, and here y equal to. In place of x, you can write any number you want. I will write here 0, and here I will write 1. The two ordered pairs were 0, 2, and 1 and 2. Of course, y must be equal to as the relation. This is called a constant relation. Another one, if we have 2x equal 5, this relation is a constant relation. X here doesn't included, the relation doesn't included y. Okay, here I will write two ordered pairs like this. In place of x, I will write x equal 5 goes to the other side, 2 goes to the other side by divide, then x equal 5 divided by 2, then x equal 5 over 2. Here x equal 5 over 2, and here 5 over 2. But in y, you can write any number. I will write 0 here and 1 here, and this the two order pairs satisfy the relation 2x equal 5. Let's solve the next one. Example 4. If 3 and 6 satisfy the relation y equal kx, then k equal what? Here in the order pair, I have x equal 3 and y equal 6. Then I will make a replacement. Okay, in place of y, I will write 6, and in place of x, I will write 3, like this. 6 equal k times 3. Okay, I will send 3, okay, or we can change the equation to be k times 3 equal 6. Okay, I will send 3 there, divided by 3, then k equal 6 divided by 3 equal 2. This is the value of k. Another example. If y minus 2x equal 1, find number 1, y at x equal 3. Okay, at x equal 3, I can find y. I will put in place of x 3. Y minus 2 times 3 equals 1. Before I send to the other side, I have to find the value. Then y minus 6 equals 1. I will send minus 6 as plus 6. Then y equal 7. Y here equal 7. Okay, the next one. Here, x at y equal 1. I will put 1 in place of y. It will be like this. 1 minus 2x equal 1. First, I will send 1 there as minus 1. Then negative 2x equal 0. I will divide by 0 by negative 2. Then x equal 0 divided by negative 2 equal 0. Then the value of x equal 0. Then x equal 0. This is the value of x. Let's solve the next example. Here we have example 6. 3 and 1 satisfies the relation y minus 3x equal a. Find the value of a. Here I will, in place of x, I will write 3, and 1 here is y. Okay, I will replacement this one. Here I have 1 minus 3 times 3 equal a. Then 1 minus 9 equals a. Then 1 minus 9 equal negative 8. equals a, and this is the value of a. Example 7. Find the value of b where negative 3 and 2 satisfy the relation 3x plus by equal 1. Here x and this is y. I will put in place of x negative 3 and in place of y 2. It will be negative 3 times negative 3 plus b times 2 equal 1. Okay, negative 3 times 3 equals negative 9 plus b times 2 equal 2b equal 1. I will send minus 9 there as plus 9, then 2b equal 1 plus 9 10. I will send 2 there to be divided by 2, then b equal 10 divided by 2 equals 5, and this is the value of b. The next example. Here we have in example 8, find the value of k where k and 2k satisfy the relation x plus 2 x plus y equal 15. Okay, this is x and this is y. Don't forget, I will replacement in place of x and y, and then k plus 2k equal 15, k and plus 2k equal 3k equals 15. Then I will send 3 there as divided by 3, then k equals 5. This is the value of k. Next example. Represent graphically each of the following relations. Number 1, x plus y equal 2. Now, this is the question. Represent graphically. The first step, I'm going to write a table like this. Okay, here I will write x and y. In place of x, you can suppose any numbers. For example, I will put 0, 1, and 2 because this is the easiest numbers. Okay, here I will put 0 plus y equal 2. Then 0 plus y equal 2, 0, then y equal 2. Okay, here 1 plus y equal 2, then y here equals 1. And here 2 plus y equal 2, then y here equals 0. Okay, I will draw these points on the graph like this. 0 and 2 will be 0 and 2 here in this position. And 1 and 1 will be here and in this position. 2 and 0 will be here in this position. Then I will connect them by straight line like this. It's clear, it's very easy, okay, to represent this on the straight line, on the graphically like this. Okay, another example. Here number 2, y minus 3x equal 1. Okay, first I will write the table. Here x and here y. In place of x 0, 1 and 2 in place of y. Okay, first, if x equal 0, then I will put 0 here, then y minus 3 times 0 equal 1, then y minus 0, then y equal 1, here 1. The next one, if x equal 1, then y minus 3 times 1 equal 1. 3 times 1 equals 3, then y minus 3 equal 1. Send 3 there plus 3, then y equal 4. Here y equal 4. Okay, the next one, if x equal 2, then y minus 3 times 2 equals 1. 3 times 2, 6, and y minus 6 equal 1. Send 1 there plus 6, sorry, then y equal 1 plus 6 equal 7. Then here I will write 7. Then in the graph we have 0 and 1 here, 1 and 4 here, 2 and 7 here. Then I will connect between them by a straight line like this. Okay, the next example. In this example, the relation 3x minus 3x plus 8y equal 24 represented by straight line intersect y-axis at the point. Before explaining the steps, I need to represent or to explain what the meaning of intersection with y-axis or x-axis. If we have, for example, like this is the x-axis and this is y-axis. The line intersect x-axis here and intersect y-axis here. For example, if this point equal 2 and this point equal 1, for example, it's for example, no more. This point will be 2 and 0. And this point will be 0 and 1. What does it mean? If I need the intersection with x-axis, here y equals 0. And the intersection with y-axis here, x equals 0. Okay, they are opposite to each other. To find the intersection with x, put y equals 0. And to find the intersection with y, put x equals 0. Then, here in this example, I have order pair. This order pair will be like this. Okay? I need the intersection with y-axis, then I will put x equals 0. Okay, then now I need y. I need x equals 0, then I will cross x like this. Then 8y equal 24, 8y equal 24, then y equal 24 divided by 3, 24 divided by 8, it's equal 3. Then the point will be 0 and 3. Another example. Number 2, if 2x plus 7y represented by a straight line intersect x-axis at. First, to find the intersection with x-axis, we put 0 in place of y. Then we will cross y like this. 2x equal 14, then 2x equals 14. I will send 2 there, divided by 2, then x equal 7. Then the point here will be 0 and 7. And this is the end of our lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.